The overall goal of the following experiment is to prepare extremely pure and precisely defined organometallic molecules on surfaces so that structure-reactivity relationships and ion surface interactions may be characterized using a combination of in situ SIMS and IR spectroscopy techniques. This is achieved by first preparing a solution of the organometallic compound in methanol and loading it into a syringe pump for injection into an electrospray ionization source. As a second step, collision-induced dissociation is performed in the high-pressure source region of the soft landing instrument, which removes one bipyridine ligand from each doubly charged ruthenium tris bipyridine ion, forming highly reactive undercoordinated doubly charged ruthenium bis bipyridine ions. Next, mass selection is achieved using a quadrupole mass filter followed by soft landing in order to prepare surface-bound organometallic ions without any contamination from unwanted species, solvent molecules, or counterions. SIMS and IRRAS are used for in situ characterization of the surfaces. Results demonstrate organometallic ions immobilized on self-assembled monolayer surfaces by soft landing of mass-selected ions.
The main advantage of this method over existing techniques such as spin coating and drop casting is that mass selection enables atomically precise control over the size, charge state, and composition of materials delivered to surfaces.
This method can help answer key questions in the energy storage field, such as whether the size and ionic charge state of redox-active metal oxide clusters can control their structure and stability on surfaces.
Though ion soft landing provides insights into the sensitivity of catalytic and energy storage materials to size and